Wait, why trying to put it first? If you would take effort, close you get 50. She would have won 36%. It's okay. It's a 50.
Okay, folks.
Yeah. Oh, and you just give me. Is there a similar in here?
Oh,
sorry. Thank you for giving us another unit, Rusty. It's appreciated.
Oh, of course, no problem. Okay, so oops. Let's bring it back. Let's bring it in a little bit. Bring it in. Okay, so this unit is our last unit. And look at this test. May 19th, the final. Do you know what the final is? It's a Tuesday. I think it's June 3rd and June 3rd. So after this unit, we're gonna have our review, and then that will be it.
Wait, how many classes do we have to review?
Yeah. I think it's 3. At least two. I'm not sure. I had to look at the calendar.
When did you get
the packet? Probably after this unit.
Right.
After this unit.
No.
Let's bring it in. Yes. The final technically includes everything since kindergarten. Probably not geometry though. But right, like I can't take out addition. I can't take out solving basic equations. I can't take out positive negative numbers. What if I did? That'd be amazing. You don't have to remember how to count anything. Yeah, nothing like that. Nothing from kindergarten. No. So, and it's going to be focused on the second semester though. That's where we will be concentrating our studies. But we can't just take out like solving basic equations and graphing lines. That'll be part of it. Yes.
Like if we've had 1 grade in the class the whole time, we just like do badly on the final. Like, are you gonna feel some like sympathy?
If you have 1 grade, like if you got like A minus, A minus, A minus, A
like,
minus,
yeah,
A minus.
like you did the same like the entire year, and you just happen to do badly on the final.
Then I'll feel really bad that you
But
did
you
poorly
won't,
on the
like,
final.
there's no like.
Yeah, we'll cross these bridges. If you're performing at a certain level all year and there's a drop at the final, then we need to figure out what happened. That generally doesn't happen. And if it does, then that's called dropping the ball. And when you do, there are consequences. So let's not drop that ball. Please. It is painful. It has happened. It's not going to happen to you. I can tell. You got this. Yes. That's a great question. Rounding, I never round until maybe the end of the year. And rounding really is a conversation that you and I have. So if you're like at a 92.8, that's a painful place to be because technically that's a B minus. That line is 93. I said that's an A minus. An A minus. That's definitely not a B minus. I just dropped the ball. So yeah, let's say you're at 92.8. But is that a result of like extreme efforts of like, were you at 92 and you've been working really hard to bring that up? If so, then I'll probably round up. But if you were at 93.5 and 93 like if you were above it and then that final brought it down to 92.8, it's probably not going to round. It's probably not. So it's a conversation. It's contextual about what you're doing. But your focus really is just do the best you can and trust that the mark that you get reflects your efforts and your mastery in the end. And if it doesn't, we need to figure out why moving forwards. Yes, Ella.
Is the title 10%?
Yes, 10%.
And it replaces the lowest.
And it replaces the lowest second semester test.
Also, on the syllabus, I think we like talked about this. It says the lowest quiz is going to get dropped. Is that yes?
Oh, did it say it on the syllabus?
I was sent this and then it's on the syllabus.
Okay.
And then checked with the math department and the math department said that was it.
Okay, I guess
So, yeah.
if it's on the syllabus, then yeah, I'm definitely doing that. I completely forget because I think this might be the first year and I have I have long-term memory problems apparently. So, but if I see it, it's perfect proof. But let's live in the moment for a while, shall we? Or in the future, just a little bit. For this unit, we have 2 quizzes. And I'm thinking about shuffling you one more time after the or for the first quiz, like April 30th. I'm thinking about shuffling the students one last time. So, and that'll last for the rest of this unit and the review for the final. So yeah, we have these two quizzes, and then we have our test on the 19th. And that's, I believe it's already on the hub calendar. So this last one, by the way, really, really good job on that last assessment. That will come in handy for advanced pre-calculus or pre-calculus, wherever you happen to be going next. And this will also come in quite handy. So I need to go to the right folder. Yeah. Let's do it. Logarithmic and exponential functions. Have you studied logs before? Logarithms? Does it sound familiar? A couple of you have. We will be doing logs. Before we do logs, we have to work on exponentials.
This next year. How stupid we are.
Oh, really? You finally won't be stupid. Yay. But so you know where the button is on your calculator at least. Okay. But now you'll know what it is doing. You will probably need a calculator for this unit, yes. I don't think you'll need one for today, but we'll see. Okay, so an exponential function with base b is a function of the form b to the x. So b is a constant, and b must be greater than 0, and b cannot be equal to 1. And think about it, if we have that function y equals 1 to the x, no matter what the input is, the output would always be 1. So that doesn't, that's just a constant function. That's y equals 1. That is not exponential. So b has to be greater than 0, and it can't be equal to 1. So these are exponential functions. Y equals 5 to the x. F of x equals 2 times 3/4 to the x. That 2 would just serve as a what to the parent function. It's a stretch, isn't it? 2 times that exponential is on the outside. What kind of stretch? Vertical stretch, because it's on the outside. If we had something like y equals 3 times 0.4 to the x minus 2, that's also exponential. The base is, in that last one, the base is 0.4. And that 2, that x minus 2, the 2 serves as a, what does it do? Show me what that x minus 2, the 2 does. Moves it to the horizontal. It's just like the basis. It's x minus x plus. Same things with the exponential, but we don't have a clear visual of an exponential function yet, so it's very nebulous right now. Yeah, to the right, excuse me, 2 to the right. Okay, so why are these not exponential functions? So the first one, not exponential, because what is that first one? Well, actually, discuss with your neighbor. Why aren't these exponential functions?
Oh, it's I guess I have oh, because X is like wait, I don't know. X is not. And then I don't have oh, I feel like yeah.
Okay, so let's talk about these. The word that should come to mind when you see that x squared is quadratic. So quadratics and exponentials are not the same function. But just, it also doesn't qualify. The exponent has to, so the variable must be the exponent to be exponential. This one, we already talked about it. This is just y equals 1. This is a constant function, not exponential. What's wrong with this one? B has to be greater than 0. B cannot be negative. And, oh wait, is this last one exponential? Did I get you? Or is that last one exponential? No, the base has to be a constant. It has to be a number. It can't be a variable to a variable. That's like super exponential. That's something you're going to talk about in Calc BC or Calc 2. We label it as variable, but B is a constant. It's constant greater than 0. Notice it's f of x. So x is our variable. Say that again. It has to stay the same. And thank you. That I should make that clear here. B is a constant. And it's greater than 0. To be perfectly clear, B is a constant greater than 0. You'll notice that this, does that qualify as an exponential function? If yeah, it does. It models the average amount spent, f of x, in dollars at a shopping mall after x hours. That's the average amount that's spent to the nearest dollar after 4 hours. To do this, all you have to do is 4. I'll plug in a 4. So f of 4. Mackenzie, I'm counting on you because I'm having a hard time doing this when I'm in my head. And I see you have a really nice calculator. Mackenzie, I'm counting on you to lend at least your calculator. This isn't a problem to type in your calculator, right? You know where that exponential.
No. Come on.
Yeah. I want to know cents. 249. 0.92. 0.92. 0.93. So average amount spent after 4 hours is that much. According to this model. It looks like y'all have to get out your calculators for these. I'm sorry I don't have mine. You don't have yours, just share with your neighbor. Your neighbor doesn't have one, just patiently wait for us to have this.
My calculator is beautiful. Oh, look at my calculator. I got what is my average to 8.66 times there's 1% error on the last one times 10 to the negative 7 instead of 1.7.
Around 3 decimal places were not specified. Thank you.
I know, I forgot. It's here. It's the second on the fourth one. Oh,
Did you get them?
Nine.
Joanna, what'd you get for A? Zero 0.117. Do we agree with Joanna? Do we agree? Okay. Okay, so you had nods. If you didn't get that, one of you is wrong. I'm not doing this. I'm not verifying. For B, thank you. Charlotte, did you get B already? 113. Anyone else get that? Here we have verification coming from this cluster in mass. Nice. No one else. There's obviously like the 4 of you just went yes at the same time. No one else did anything. I think Joanna did. Thank you. By the way, When you use pi for your calculator, you don't do a 3.14, right? You know the pi button.
Yeah.
Please make sure you're using that. Yeah, that will save you some heartache. And finally, the last one, Sam. You get it? 0.413. Do we agree with Sam? Yeah. That time was middle row. That agreed. Okay, interesting. Just really briefly, would you discuss with your neighbor what's another way to write this? What's just really what another way to write 2 to the neighbor? Show me the top. The top is 1, and the bottom on the count of 3. 1, 2, 3. 2 to the pi. All right, sometimes we forget these things. So that's the exact same thing. If you do 1 divided by 2 to the pi, you get the same value. Okay. So you know I hate t-tables, right? Taking tables of values, I hate them. But when we're making parent functions, I think it's perfectly appropriate to make them. So here we go. I care about 3 x values. -1, 0, and 1. But we're going to do a couple more. Maybe we'll go all the way up to 3. Go ahead and fill in the y values, please. Elise, what are you doing? What did you answer for Elise? You just answer for Elise?
Yeah.
You're a good friend, yeah. There, you got them? Did you graph them?
Oh.
I'll write the answers here. Make sure to check my word because I may have made an error. That's good. Well, you should have a nice, it should not look jagged. Be nice and smooth. And you see where it's going to the right and where it's going to the left. You're right. You're left. So we have this. And we have, how low are these values going to get on the left side? I keep approaching 0. So the x value is that the x-axis is called an asymptote. And every exponential function has a horizontal asymptote. So this is a parent function, 2 to the x. You can imagine stretching it, moving it left, right, up and down. You can imagine all that, just like we would with other functions. 3 to the x, is that some sort of transformation of 2 to the x? No, it's a different kind of parent function within the same family. Can you do a quick sketch of this graph? I'm gonna call on someone to help me with some points. So just check with your neighbor, make sure they got the same thing you did. Okay, Kara, could you tell us what you've done so far? Okay. Okay. Am I summarizing these okay just by finding the coordinates? Are you okay with that? Okay. Okay. And did you plot anything on the other side? Perfect. I love that. It's divided by thirds going to the left. Does that make sense? Like to the right is being multiplied by thirds, so left is being divided by thirds. And remember, there are only 3 points that I really care about for these. I just care about when x is equal to -1, 0, and 1. I just care about those 3 points. So when you're doing your graphs, those are the three that I want for sure. The others are kind of a bonus, and I'm throwing them in here for just educational purposes to see where it's going. But those are the 3 points I want you to have. It's kind of like a vertex and the two other points on a parabola. So this one is going to look a lot like the first one, except it is steeper, isn't it? You can imagine 4 to the x, 5 to the x, 12 to the x, all exponential functions getting steeper and steeper. Domain range, easy. Would you just make sure your neighbor knows the domain and range?
Oh, yeah,
Okay. So maybe it's domain and range, please. Okay. Are we good? Thank you. Okay. Oh, another one. There you go. Have fun. Daughter.
I know, but like this, sorry, yeah. No, but how do you say it in like the conditional simple?
I'm daria.
Simple, daria. Una nota A.
Sí. Nice.
Si tu fuera el presidente de la escuela daría más dinero.
Oh, thank you. You can get that message to somebody. Okay, do I get example 3? At least you get extra credit for that one. Double extra credit. Yeah. Triple for doing it in Spanish. Do you want to call on someone? So make sure that you get values here. Okay. Jojo, can you tell us the points that you got here, please? Is that right? -1, 2. Nice. Okay. Would 2 points be enough to get a good graph going here? It's kind of linear, isn't it? If you know that horizontal asymptote, I guess it really is enough. But you know that I want all 3, so thank you for doing that 1, 1/2. And I think we are good here to graph the rest. We could get some more points. I think -2 will give us that 4, and then look at that 8 going here. So I'm going to do that way. Okay. Thank you, Jojo. Did you realize what went from Maymay to Jojo? You never know, though. I call them Maymay, then I call them Jojo. It's just an interesting sequence. Okay. So you notice that this is different from the other ones. The other ones were exponential growth, whereas this one could be described as exponential decay, is what we call this, decay. And what do you notice about the graphs in 2A and 3? Discuss, how does it fit with your knowledge of transformations?
Wait, okay, si fuera,
En inglés.
the 1/2, the 1/2, sería una revolución la axis. Wow. I don't know, I don't think it's bad. There's never been something Wait, what's
Okay. What'd you find? Who'd like to tell us the connection? It's reflected over the y-axis. Okay, what else? Like if we were to start with this 2 to the x and we want to reflect that over the y-axis, then we'd have to change what to what to reflect it over that y-axis. Would it make sense? Y equals 2 to the negative x. That flips it over the y-axis. Does that make sense? Which is the same thing as 1 over 2 to the x. So is that the same as example 3? Yeah, 1 to the x is just 1. So this is the same thing as 1 over 2 to the x. Yeah, so this is equal to the 1/2 to the x. So they're just equivalent ways of writing the same thing. That reflection over the y-axis. 2 different ways of thinking about it. You put on both. There is a over b to the m, but this is equal to a to the m over b to the m. But if you have 1/2 to the x, then 1 to the x over 2 to the x. What is 1 to the x? It's 1, so you can simplify that. So they're just equivalent. But that was kind of a aside. Let's talk about characteristics of the functions. So domain, we already know, is -infinity to infinity. The range of b to the x is 0 to infinity. We can see just with the 3 we've done, it's only going to be positive numbers coming out of the exponential function. The graphs pass through which point? 0, 1. Because f of 0 equals b to the 0, which equals 1. Therefore, the y-intercept is 0, 1, and the x-intercept non-existent. If b is greater than 1, the graph is think about how you would talk about 3 and 4. Look at the 3 that we've done. The 3 graphs. How would you fill this in?
No, yeah, instead, I'm not gonna that.
Okay, so b is greater than 1. What's a good word to use? Either growth or something we've used in the past. This function is increasing, isn't it? Would that make sense considering what we've done? Increasing. But growth is perfectly acceptable here. And if b is between 0 and 1, like with that 1/2, it becomes decreasing. But very specifically, it's a decay function, exponential decay. We know that f of x equals b to the x has an inverse because it is discuss that one. You know this one. Sam, make sure to discuss this one with Charlotte. Sam, you okay? Make sure to discuss this one with Charlotte. Number 5.
I don't know what it's.
Looking for 3 words here.
I agree.
3 words, including 2 numbers. Because it is a 1,
1-to-1.
1-to-1. How do we know that it's 1-to-1? It passes the vertical line test and the horizontal line test. Right? That's how we know it has an inverse. 1-to-1. It's been a while, hasn't it? Yeah. The graph of f of x equals b to x, but approaches but does not touch the x-axis. The x-axis, or y equals 0, is a horizontal asymptote. Do you remember how to spell asymptote? P-O-T-E, thank you. This is not an asymptote. Asymptote. Let's see, what else do we have to talk about here? So far, so good? Should be pretty intuitive. Okay, folks. Before we do this, let's just finish this. So the parent function is y equals 3 to the x, and the transformation is, thank you, 1 to the left, isn't it? How do you know it's to the left and not like up? Inside the function, happening directly to the x, so it's 1 to the left. So I'm gonna make my 3 points for my parent function and make this dashed.
Definitely confusing. No, that's what I'm right? Wait, outside, this is vertical stretch. Vertical stretch. Oh, wait, there's this, I hope not. Vertical stretch two. It should be one. That one to the right. And pull down. Right? Yeah. Yeah. So 1/3 to the F. Oh my God. Wait, 1/3 to the negative one. Wait, the first option is 3 to X, right? And the one of the no, but it's 3 to X, and the one of the function of y. Right? I'm going to say function of one of the.
About 1 more minute, then we'll go over these. Just B and C. We'll do D together. Yes.
We start with 1/3 to the X is the main function, 3 to X is the main function, and 1/3 is the like what you're in the y.
Either way works. I would do 1/3 to the X. I know.
One. And then moving it one way this way. Moving it down. Stretching it first.
Okay, folks. If I could get your attention, please, let's talk about these. Is 3 points enough for the parent function, or would you be more comfortable with one more? It seems like a 2, 4 is reasonable, just to continue getting the curve. So even though I'm just requiring the 3 on like a test or quiz, unless it says more, of course, feel free to put more points. So this is a parent function, and I need some help. Haley K, what's going to happen to all these points? Thank you. 1, 2, 3. So like here, here, and here. Did I do that right? And here?
Oh, no.
No. 1, 2, 3. 1, 2, 3. Okay. Cool. And in order to draw my graph, I want one more thing. It's not a point. I also want to see the asymptote. So that, yeah, so I could approach it with a half arrow. The equation of the asymptote is y equals -3. The asymptote is always dashed. Why is it dashed? Because what? Well, it could be solid and you never hit it. Why is it dashed not solid? Not over here. It's pretty far. Should I just make it dark on the right and yeah. There's a specific reason why it's dashed and not solid. Yeah, it's not part of the function. It's a guide for the function, something that it approaches. If you make it solid, you're saying this is my function. And now that we have our points, we can make that nice function, kind of like that. Yeah. Thank you, Hayden. Next. See. Would you please all show me the transformation that's happening here? And this negative is the inside or outside the function? It's outside the function. This is saying negative, basically the same thing as saying -1 times 2 to the x, isn't it? So this is outside the function. That's why it is reflected over the x-axis. Okay, I'm not going to call anyone for that because I think we already kind of just did it. So this is what I'm looking for. It makes sense. Number D. So we would say here something like reflect over x-axis. Okay, yeah, D. I don't want to just plug in like 0, -1, and 1. I want to start with the parent function, and then I want transformation. So who's prepared to tell us the parent function, and then the transformation? Ms. Kennedy.
Or
So y equals 1/3 to x. Okay.
and then like the starting points, we can do 1, 3, 0, 1, and then 1, 1/3.
Is that pretty good approximation for 1/3? Good enough.
And then, scratch on the first slide, I just did it 25 seconds, so like.
Wait, so let's list them first. You said stretch.
Stretch everything, all that.
Stretch.
counts. Two,
Okay, so vertically by 2.
one, that way,
1 to the right,
and then 4 down.
4 down. Are we good with that? That's exactly what I'm looking for. And what has to come first? We have all these 3. The stretches or reflections have to come first. Okay, so
So 1/3 becomes 2/3.
mhm.
For 1, and down there.
Just like right there.
Two. I actually don't know what that one is. 2, 4, 1.
Negative 3 and 1/3.
Um,
Just a minute. Are we okay with that? Is it negative 2 and 2/3? I think it draw. Well, let's see. If I move it down, it went here. So first, let me do this in a different color. Went to here, then it moved to. So it went to 2/3. Then it went here to the right. Then it went down 1, 2, 3. I think it's okay. Since we crossed over that 0, it's in there. Okay.
the second one, is over 1, times 2, which is 1 to 2, and then over 2. Sorry, not over 0 to 1, then down. We have 1.
Okay. Okay.
The last one is over 1. It's times 2, but I did times 2 and then I did 1.
Right. Okay. Zero, negative 1?
0,
0, 2.
0 is 0 is second.
Okay. Cool. And what else will we need to help us draw our graph? Asymptote. Always dashed. Does this seem like it's getting anywhere? Is it going to give us a graph? And it better be exponential. Beautiful. Thank you for helping us with this. Very nicely done. So yes, we could have gotten those same points by plugging in 0, 1, 2. We would have gotten the exact same things. I really want you to focus on your transformations from the parent function. Any questions? Determine whether a function is linear, exponential, or neither. Discuss.
Well, that's the question. If you don't need a special, wait, how is it? C is neither. It goes negative, positive, negative, positive. I think it's linear. Yeah, it's linear. I don't know.
Okay. So A, what do you think? Linear, exponential, neither? How do you know it's linear? Yeah, that's called the what of the function? That's the slope, isn't it? Up 3 over 1, up 3 over 1. So if there's a common difference like that, it is linear. A B, how do you know it's exponential? You see every time it's being multiplied by 3 over 2, is that right? So 3 over 2 would be the what of the function? It's the base. So C, but isn't there a times though? Can we do like times -2? Isn't that okay? Is it exponential? Yeah, the base that repeated quantity can't be negative. So this is neither. B has to be positive. So this is exponential. This is linear. And Any questions? I'll give you a few minutes. Right now it is 25. So we'll begin again at 28. There's gonna be time for homework for sure.
Right?
I have one more question.
With the opposite one next time. Well, I think it depends. Most of the time, neither. I'm most of the time I say neither. 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 I say.
No, in Spanish, when you're saying like, you're saying like mine.
I think neither more than something.
Although we had the podcast like this class. Yeah, I remember. No, it was the funniest thing I've ever had, because we were just like, he was like, we're like, si tú like, okay, si fueras un chico, wait. Si fueras un chico, te llamarías. He said it. Tengo un conocido de second see, like, I don't know. What? You had noticed that. I know. Oh my god. He's like, they act. He's like, I'm a friend. That's what we wrote down. I read the horse. He always says, it almost is the main. Yeah, we had tattoos. Say. Oh no.
About 15 seconds.
I'm really the translator of my Spanish class. I'm like actually really good. I understand why no grammar here, and I was learning like that. I don't know. I don't know. Also,
Okay, folks. Here, have a seat, please. One last question. And you don't have to write this down, by the way. My question for you is, you know that already that this is not exponential. It's not exponential, right? There's no sort of transformation that can happen here from 2 to x. The base is changing, not the function that's being multiplied by anything in particular. So why is it not exponential? Like, why does the base have to be positive? Think about it. Why? Like, what's wrong with this? Yeah, I'm seeing some gestures. Does this make sense up and down? Plug in a 0, yeah, you get the same one, but if you plug in a 1, you get -2, then if you plug in a 2, you get +4. Does this look like it's going to be an exponential function? It almost looks sinusoidal, but there's other problems aside from the fact it bounces back and forth. Any idea what another problem would be? Yes, Jojo? It doesn't have an asymptote, and something's gonna be controlled down here. So maybe there's an asymptote. But aside from that, one interesting thing that's problematic here. Yes, Katie? It's getting bigger and bigger. Well, exponential gets, but you have big positive, big negative. Okay. What else? Looks like you're thinking for very big numbers. But how about numbers like in between the integers? Like what is -2 to the 1/2? Please discuss your neighbor. What is 2 to the negative 2 to the 1/2?
Error, non.
Yeah,
That's like that. Like the imaginary story.
yeah. E?
It's like
No.
an asshole.
Yeah. Oh, we're getting there. We're getting to E. Yeah, so not only do we have 1/2, but we also have like 1/4 and 1/6 and 1/8 and 3/8. Just there are too many values that don't exist in between. So not only do the integer values bounce back and forth, the ones in between are some largely non-existent. So we just forget about it. It's too complicated. Let's keep the base positive. Okay, folks, that's all that we have for the lesson. You have some time to work on your assignment. I hope you liked exponential functions.
Okay, the negative log of the concentration of each one. So if you have a molarity of, let's say, 0.55 milliliters of a strong acid, right? The strong acid is ionized at 100%. So that means that like there's going to be the same concentration of each pluses as there will be original acid, right?
Okay.
I'm like 0.5 molarity moles per liter of a strong acid.
Okay.
You can tell me how to tell you go negative loss of the concentration of each plus was concentration of plus same concentration of the acid of ionism. The strong acid. I don't know why.
I'm gonna send this to your science